Hello and welcome to the third and final video in the ESD tutorial series, ESD Advanced Topics. In this video, we will cover advanced functionality of Morningstar's external source control feature, including combinational logic and multi-schedule programs. If you haven't seen the first two videos of this ESD tutorial series, I'd encourage you to go back and check those videos out first. Before we jump in, let's review how to get into installer setup. We do this by entering the installer password here and clicking the Enable button. We now have full access to the installer setup menu. For this video, we will once again be spending all of our time in the ESC tab under installer setup. You can see that we have our ESC control signal already assigned to a relay, which we covered in the first video. We're going to start from scratch on our program this time, so we can show you how combinational logic works when defining stop and start criteria. We can clear out any existing schedules by clicking the top right X button on each schedule card, like so. We now have a blank slate. Great. Let's create a new ESC program for a hypothetical hybrid solar system that has the following components: a small PV array, a Morningstar GenStar charge controller with both a ready shunt and a ready relay block, the system battery, a fuel cell generator that provides supplementary power during cloudy days and winters with fewer charging hours, and an auxiliary AC battery charger that the customer can use for service charging when AC power is available. We also have two shunts in the system. The first one measures net energy in and out of the battery for accurate state of charge, and the other shunt measures the charging current from our AC battery charger. We will use the ESC feature to control our system's fuel cell in a smart way. Let's define some needs and constraints for the fuel cell operation. First, 7 days a week from noon to 10 p.m. The fuel cell must provide supplementary power as necessary so that the battery reaches 80% state of charge daily. Also, the fuel cell should not run if the solar charge current into the battery is greater than 20 amps. In other words, we want to save fuel and not run the fuel cell if solar production is strong. Constraint 2. Every Sunday at 7 p.m., the fuel cell should charge the battery to 100% state of charge. Constraint 3. 24 hours a day, 7 days a week. The fuel cell should not operate any time the auxiliary AC battery charger is running. And lastly, constraint 4. On Mondays and Wednesdays from 6 a.m. to 7 a.m., never run the fuel cell. It's quite a list, but don't worry. We'll build a smart ESD program by breaking these needs down and separating them into manageable pieces. At the end of this exercise, you'll have a clear picture of how the ESD feature can be customized to meet the specific needs of your system. To get started, let's look at part A of our first constraint. The fuel cell must provide supplementary power as necessary so the battery reaches 80% state of charge each day. As we saw in the previous videos, defining start and stop charging schedules is quite easy. First, we create a new start charging schedule. Next, we'll go ahead and edit the start and stop criteria. Let's use custom settings for start charging. Click on Add Condition. And now we simply need to edit the default conditional statement to get exactly what we need. In this case, we need to start charging when state of charge of the battery is less than 80%. Battery state of charge less than or equal to 80%. And let's leave the 1-minute filter value in place. Now we need to edit the stop charging criteria. You can click on the wrench, click Add Condition, and again, we will modify this so that it says battery state of charge. But this time, we need to stop charging when the state of charge is greater than or equal to 80%. And we'll keep the default filtering in place on this one as well. Let's go ahead and read our new Start Charging 1 schedule. We will start the fuel cell when the battery state of charge is less than 80%. And we'll stop the fuel cell when the battery state of charge is greater than or equal to 80%. Now the criteria also said that this is in effect 7 days a week from noon to 10 p.m. So let's go ahead and modify our schedule. It's still every day, but it's not all day. We're going to modify this so it says noon until 10 p.m. or 2200 hours. And we'll go ahead and click Save. Now we've satisfied Part A of our first constraint. Part B of our first constraint says that the fuel cell should not run if the solar charge current into the battery is greater than 20 amps. Essentially, we want to pause the fuel cell if the solar production is good for that particular part of the day, and then resume if it gets cloudy or dusk. This is a good use for pause charging schedule, so let's go ahead and add that to our program now. We will once again edit the conditions for the schedule to get exactly what we need. So let's go ahead and edit the pause charging criteria. We'll add a condition, and in this case, we want to use the GenStar charge current as our control variable. If the GenStar charge current is greater than 20 amps, and let's go ahead and modify the filtering a little bit here for 5 minutes. We want to make sure that we're on a nice sunny day and we've got consistent solar production. And click OK. We will resume the fuel cell. Let's go ahead and edit, add condition. If the GenStar charge current, the solar production, has decreased to some amount. Now let's go ahead and make up our own here. We'll say if the solar current is under 10 amps for 5 minutes, a little bit more filtering there, and click OK. So let's go ahead and review the pause charge schedule. We will pause the fuel cell when the GenStar solar charge current is greater than 20 amps for more than 5 minutes, and we'll resume use of the fuel cell when the GenStar solar charge current is less than or equal to 10 amps for 5 minutes. And again, this is 7 days a week from noon to 10 p.m. So let's go ahead and modify our schedule from noon to 2200 hours and click Save. We've now set the conditions for our first constraint. For constraint number 2, the fuel cell should charge the battery to 100% every Sunday at 7 p.m. In order to do this, let's go ahead and add an additional start charging schedule. Same as before, we're going to go ahead and edit our start and stop criteria. We want to start charging if the battery state of charge is less than 100%. And we want to stop charging when the battery state of charge is greater than or equal to 100%. So let's go ahead and see what we have here. We will start the fuel cell when the battery state of charge is less than 100%, and we'll stop charging once the battery has reached 100%. Now this needs to occur every Sunday at 7 p.m. So instead of every day, we're going to say Sunday and remove the rest of the days from the schedule. And we're only going to do this at 7 p.m., 1900 hours. Now, we want to make sure that the fuel cell has plenty of time to bring the battery to 100% state of charge before the next solar charging day begins. We can specify, for example, 6 o'clock in the morning. The program is smart enough to know that if the end time comes before the beginning time, that its assumption is you're going to roll over past midnight and continue charging till 6 a.m. the next day. This gives us plenty of time for our small fuel cell to get the battery topped up before the next solar charging day. Let's go ahead and save our work. And now we've satisfied constraint number 2. Now let's take a look at constraint number 3. in effect 24 hours a day, 7 days a week. The fuel cell should not operate anytime the AC battery charger is running. In order to do this, we need to modify both the Start Charging 1 and the Start Charging 2 schedules so that we will not start the fuel cell if the battery charger is running. And if the battery charger starts running while the fuel cell is operating, we need to stop it. So let's take a look at the Start Charging Schedule 1 first. Click on the wrench to edit the start criteria. Our existing condition is already here. We will start when the battery state of charge is less than or equal to 80%. But now we're going to add an additional condition. You may remember from the intro system diagram that we have a shunt placed on the output of the AC battery charger. So we can measure the current output of this charger, and we can use that as our control variable. So let's go down the list to shunt data and select the AC charger shunt B amps, which is the channel we are measuring that current. Now, in order to start charging, we don't want any current output from this charger. So we'll make sure it's less than or equal to 0 amps. Now let's take a look at our conditional statement again. We will start the fuel cell when the battery state of charge is less than or equal to 80% and the charging current from the AC charger is less than or equal to 0. Now we will edit the stop criteria. Add a condition again. We're once again going to use the current. And this time, we're going to stop the fuel cell if the AC charger is greater than, let's say, some small amount of current, 1 amp. However, you'll notice that there is a selection box up here, all and any. So we have two conditions stated. If all is selected, it means that both of these conditions must be true in order to stop. But in our situation, we want either of these to be true, so we can select any. So whether the battery state of charge is already reached 80% or the current from the AC charger is greater than 1 amp, we will stop. Both conditions do not have to be true for the stop condition to be initialized. And we'll click OK. So let's go ahead and look at our newly modified Start Charging 1 schedule. We will start the fuel cell when the battery state of charge is less than 80% and if the AC charger essentially is off, no current produced. We will stop the fuel cell when the battery state of charge reaches 80% or if the battery charger turns on. Now we will also modify Start Charging 2 in exactly the same way so that we have these additional conditional statements. We've now modified the Start Charging 2 schedule in very much the same way. So let's move on now to constraint number 4. Mondays and Wednesdays, 6 a.m. to 7 a.m., never run the fuel cell. This is a job for the prohibit operation schedule. So let's go ahead and add that to our program. The prohibit operation only runs on a schedule. There are no other conditional options. Prohibit operation is essentially a blackout schedule, which means when you specify hours, there will be no starting and no stopping of the fuel cell during that block of time. So all we need to do is go in and edit our time from 6 a.m. to 7 a.m. on Monday and Wednesdays. And that's it. The fuel cell will never run between 6 a.m. and 7 a.m. on Mondays and Wednesdays using the prohibit operation schedule. Go ahead and save your work. Congratulations, we've now satisfied all 4 constraints. So before we break, I want to go ahead and cover just a couple more things. You can go to the schedule summary and take a look at your configuration and the program as a whole. We see that prohibit operation is in effect from 6 a.m. to 7 a.m. There's no operation of the fuel cell during this hour. The pause charging, the Start Charging 1 schedules, all in effect from noon until 10 p.m., Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And of course, we have our Sunday night top-off, where we run from 7 a.m. till 6 a.m. the next morning to bring the battery to state of charge 100%, at least once per week. So this is very handy, so you can see at a glance how all of your schedules line up. Now, we did cover some combinational logic when we were talking about how to pause the fuel cell during certain conditions. Let's go ahead and take a quick edit here real quick. So we have two conditions, and we could set it to any or all, which means both conditions have to be true or one of the other conditions be true. And you can add, of course, a third and a fourth condition if you want, and these can all be ANDed or ORed together as well. But there's one other feature here, add a group, which allows you to have two separate groups of conditions. You can specify that all the conditions in this group are true, and all the conditions in this group must be true. Or you could say that any or all in any combination, but you also have the option of ANDing and ORing each of the two groups themselves. So you can say A and B, or B and C, or any other logical combination you can dream up. So using groups allows you to add additional sets of criteria, grouping them together so you can do logical combinations in any way, shape, or form. So I hope you can see how incredibly powerful and flexible our combinational logic is in the ESC feature. There's no logical challenge we can't cover. I hope you've enjoyed this third and final video of the ESC series. If you have any questions, please reach out to our technical support for additional assistance. Thank you and have a great day.